Hey guys, welcome back to another episode of Unreal C++. In this one we're going to be covering HUDs, and I've told everyone I'm going to be doing HUDs for quite a while now, and I didn't really get around to it, so I'm finally doing HUDs. And I've had so many requests in the comment section, please do HUDs, HUDs in C++, and for a while I kind of shied away from the idea of doing it, but finally did a bit of research into how to draw HUDs and stuff. And so the way I'm going to be doing it is exposing my C++ to blueprints, making the HUD's blueprints, but then accessing my C++ functions. And we're just going to integrate the two really nicely, and you'll see how that all works. So this is just a basic first-person template that I've set up here. And we're just going to open up the character. But first, a little bit of groundwork. This is stuff that we need to do before we can continue on. The first thing to do is just open up your generic.h. So whatever you called your project, go into this header file. And as you can see, we've included engine minimal. We actually want to include the full engine. Let's go ahead and save that. And then we want to open up this .cs file. And .cs means C#. We don't really work with C# at all with the Unreal Engine other than these build files and target files and things like that. So if you don't really understand what C# is or the syntax confuses you, that's alright, because we don't really work with it that much anyway. But the syntax is pretty similar to C++. So anyways, all we need to do here is just add another dependency module. And we're just adding UMG. And we'll need to add a couple of private dependencies, so to add those, just copy and paste that, and then just change this to private. And in here we're just going to have slate and slate core, so slate and slate core. There we go. And those are our dependencies done. So once you've done those two changes, that's basically the groundwork. The last thing you need to do now is just come into your project here. And go to your Unreal Engine project file, right click, and then go Generate Visual Studio Project Files. So just go ahead and click that. It's going to generate all the project files that we need. And once it's finished with that, we can now continue on with our tutorial. You'll get this thing here, the project has been modified, just go reload all. And now we're ready to get started. So once you've got all that done, we can get into the tutorial. The reason we add those dependencies is because basically it doesn't really understand what interfaces are until we actually tell it in the build file to include that. If we didn't include that, we could still do it, but we would have to basically add a bunch of really long things on here. So we'd, as you can see, like game framework / input settings, it would be like interfaces / UMG / slate core / whatever, and it just saves us a lot of groundwork, basically, I guess you could say. So we need some information to expose to our HUD, and I'm going to make it stamina. So the player's going to have some stamina, and it's going to drain slowly over time, and the HUD is just going to show you it draining over time. So, to do that, we're going to have to add some stamina to our character. So, I'm just going to add a private section here. And we'll make these U properties. So, U property, edit anywhere. Category equals stamina. Float current stamina. And then we will make another one of these called initial stamina. So this is the amount of stamina that the player starts with, and then the player's current stamina. Now you might be thinking, well, I know that private variables cannot be accessed outside of the class, so how are our blueprints supposed to access these if they're private? And you're right. What we need to do is make it what is called an accessor function. So we make a public function that gets these private values for us. And this is called encapsulation, by the way. So if you're ever taking some sort of programming quiz or test or whatever, put encapsulation down and the teacher will be very impressed. Anyways, let's see here. Public. So we want to make the accessor function public. So, we're coming in. Accessor function for initial stamina. And I'll just copy that. And then we'll say accessor function for current stamina. These are going to be U functions. And we're going to make them blueprint pure, which means the blueprints can access these. And the category is obviously going to be stamina. And then we just say float get initial stamina. Very easy. We can just basically copy this now, and in here get current stamina. So these are the functions that our blueprint is going to use in order to get the initial and current stamina and send that to our HUD so that our HUD can display this information. We're also going to make a function that just updates the stamina. It's going to be very easy, so U function blueprint callable in case we ever need to call it from blueprints. Category equals stamina. Void update stamina. We'll put update current stamina. Float stamina. And then we'll just put a nice little handy comment here so we know what this actually does. So we'll say updates the player's current stamina. Now we're going to do something really cool here. This is @param. So this is just really helpful if anyone is ever using the blueprints. This is going to show up for them. It also shows up if you're writing C++, but also on blueprints. So since we have this parameter here, float stamina, we can actually describe what stamina does to anyone who is using our function. Really, really handy stuff. So we'll say @param stamina, and then a small description of what stamina actually does. So this is the amount to change the player's stamina by. It can be either positive or negative. And so now anyone calling this function is going to see this come up, especially from blueprints. It's really handy, and you'll actually be able to sort of understand what stamina does when you're using this function. So very handy stuff. And also I'll just add a comment here. The player's initial stamina. The player's current stamina. And there we go. Make sure to comment everything, guys. It's just going to help you out a lot later when you're looking through your code. It's going to stop you from getting confused if you have everything nicely commented. And if you ever give your code to anyone else to work on, they're going to be able to read your comments and they're going to be able to see what you're actually talking about. It's a really good practice to just learn how to do that. Now, in this case, we actually want our character to have a tick function, and we're going to use the tick function to drain the player's stamina. So if we go here, virtual void tick, float delta time, override. So this is just saying override the tick function from the base class, and then we can go ahead and implement that. So to implement that, we'll just wait for that little green underline to come up. And while I'm waiting for that to happen, I'll just implement these. So create definition. You know what, that's being... Oh no, no, it's done. Okay, cool. So return initial stamina. Can just save that. Very easy stuff. And then quick actions, create definition. I like to create the definitions this way because it kind of means that You know, since Visual Studio is doing it for you, you know it's not messing anything up, and it's gonna get all the definitions and stuff perfect. There's no way you can make any typos. But it usually doesn't take this long. This is pretty weird, so I might just start doing it manually. So here we're just gonna return current stamina. Very easy stuff. Save that. Implement tick, quick actions, create definition of tick. And there is something we need to do for tick. When we implement tick, we need to call the super functions tick, and I will explain what that means in a second. But yeah, you just need to get into the habit of doing it whenever you're overriding a tick function. So in here we just say super tick, and basically since we're overriding tick from the super class, we just call the super's tick function as well. So close that. And then lastly, we want to implement this update current stamina function, and this will be very easy to implement. Basically, it's going to take stamina and it's going to change the player's stamina by whatever value we give it. So we're going to use that inside of the tick function, and basically that will let us slowly drain the player's stamina. And then we will send it to our HUD, and our HUD will display it on a little progress bar. So you'll see the bar slowly drain as the character runs out of stamina. So in here, I'm just going to say current stamina equals current stamina plus stamina. So very easy stuff. Let's go into the tick function, which is here. Right. In our tick function, we need to update the player's energy. So we're just going to make it so it's constantly draining. So update player, update current stamina. Was it in it? No, it was stamina. It was stamina. Right. And then we say negative delta time. And delta time is just a constant value that is passed to tick. And then we're going to times that by, say, we'll go 0.01. Nah, that's probably a little slow. We'll go 0.05f. And then we will times that by the initial stamina. What this is going to do is it's going to make our stamina drain nice and slowly. And I might want to end up changing that value. Actually, I might make it 0.01. Okay. So, oh, and also we need to pass delta time to the super class's tick function. Quite easy stuff. Okay, and also we created the initial stamina and the current stamina, but we didn't actually initialize them. So let's initialize those values. Initial stamina equals 100.f. Current stamina equals initial stamina. Okay, now that we've done all that, we're almost ready to start putting our interface together. So let's just make a new folder, call this HUD, and inside our HUD we'll make a blueprints, oh sorry, where is it? User interface, widget blueprint. And we'll call this player HUD, I guess, why not? So we want to display our stamina. To do that, I'm going to use a progress bar and we'll just drag this out. And whenever I think of stamina, I always think of the color green. So I'm going to use a nice green color to represent the player's energy or stamina. As you can see, we have this value here called %. Now, this is a value ranging from 0 to 1. So if I put 1 in here, you can see it's going to be a full bar. If I put 0.5, it's half full. 0.25 is 1/4, and yeah, you get the idea. By default, we're going to make it equal to not full at all. We're going to bind a value to the progress bar, and that's going to bind our stamina. So our stamina is going to be basically displayed in this bar. Before I can access all that stuff, I'm going to have to compile all my code and make sure that's working properly. So once I know all the code's there, I can bind it in the blueprints. Jesus, any day now. My god, I've never seen C++ code take this long to compile. This is ridiculous. I hope nothing is wrong. Because if it says compile failed, that is going to be very frustrating to recompile all this stuff. Yeah, it seems slower than usual. It might be... Oh, wow, I had another project open. Maybe that's it. Ha! Hopefully that didn't ruin anything. This is truly ridiculous. I've never seen C++ code take this long to compile. There we go, finally. My god. Right. Let's open the HUD up. We've got our progress bar there. And we'll go ahead and compile our HUD. That'll compile straight away. Right. So, we have our bar and we want to bind the stamina to the bar. To do that, we're going to go bind, create binding. Drag that out, and if you just hold Alt and then click that, it's going to get rid of that link. So what we need to do is get the player character, and we're using the index 0, which is our player. Drag that out, and right now get player character just returns a generic character, or sorry, just a normal character. We want to actually cast it into a generic character, which is our character type. Keep in mind, it won't be generic character for you if you used a different project name. If your project name was Fire, for example, you would be casting to Fire character. So just keep that in mind. Because we're not working with more than one character type, we can just convert this to a pure cast, and we know that it's going to succeed because we know we're casting into a generic character always. Drag this out and get the current stamina, as you can see right there. Now, we just return this, and what we want to do is divide this by 100, because our stamina is a value ranging from 0 to 100, but you'll remember that our progress bar only takes a value from 0 to 1, and obviously that's not going to work for us. So we need to divide our value by 100. And now, our stamina is going to work as a value that is from 0 to 1. We'll just drag that in here, and it's going to do any conversion it needs to do, but since it takes a float and it's already a float, it won't convert anything. And then we just drag this into here, hit compile, and go back to the designer. So this should all work now. If you go to %, it should say get %_0. Cool, so that's all set up. But if we play, it's not going to be using our HUD because we haven't set it up to use our HUD at this point in time. What we're going to do is... Oh, I need to save this as well. So if we hit save, that's all saved now. We'll go into our game mode. And this is where that build C# file from earlier comes in. So generic. And come into our game mode. Okay, so in our game mode in the .h, we need to add some things. We need to add the interface, and then we need to add the current interface. So there's two different interfaces there. And I'll explain what all of this does soon. And we also need to override the begin play function. So to do that, virtual void override. Oh, sorry, begin play override. And we'll just add a comment here so we know what this means. Override begin play from the base class. Layout protected here because we're going to be letting another class inherit from this. So we'll say uProperty, edit defaults only. You may not have seen this before. What edit defaults only means is we cannot edit it during runtime. We can only edit the defaults before we actually run our game. Blueprint read write in case we need to access it from blueprints. Category equals stamina. And then finally meta equals blueprint protected equals true. And that is because we have a protected variable, but blueprints don't just work straight away. We actually need to say blueprint protected equals true, and now the blueprints know, okay, this is a protected variable. Then we're going to say t subclass of class user widget, and we'll call this the player HUD class. And then we're going to add a uProperty, and there's not going to be anything in our uProperty, it's just a uProperty. Class user widget, current widget. So that's the current widget that's on the player's screen, and that will allow us to cycle through different interfaces. Say we wanted to add an inventory later on, we could do that. The reason that I've added a uProperty here without any properties inside of that is basically I'm just saying enable garbage collection and stuff like that on this uProperty object, but we don't need to actually declare anything inside of it in this case. And then saying class before you use a widget is basically just a forward declaration, and I'll explain more on that probably in a C++ basics video. But anyways, let's create a definition of begin play. And in begin play, we can, first of all, what we want to do actually is call these superclasses begin play. Okay, now we need to get the character. So a generic character, my character, equals cast, a generic character, gameplay statics, get player pawn, and this is just our way. If you remember in the blueprints we said get character controller. This is the C++ equivalent of saying that. This 0. So there we go, we now have our player's character. Now we just check if HUD class, is that what I called it? Player HUD class is what I called that. If player HUD class is not equal to a null pointer, so if it is equal to something, if it has been initialized, current widget, so the player's current widget on the screen, equals create widget, and create widget right now is not going to be available. You'll see in a sec if I type in user widget, and then we just pass the world to that, and our class, which is player HUD class. So create widget, it doesn't know what that is, and that's because we haven't included it. So if you come up here now, we can now say include blueprint /user widget.h. Now, if we didn't add those dependencies to our C# file, we would need to type a lot more stuff than just blueprint /user widget.h. So we're just saving ourselves a bunch of work there, and just making things a lot easier for us. And then once we've created current widget, we just null check that as well. So if current widget is not equal to null pointer, current widget add to viewport. There we go. Right now that's not working, and I'm pretty sure that's just because IntelliSense hasn't loaded all that stuff yet. There we go. Yep, that's all working now. Alright, very good, guys. That should be it, I believe. We just need to do like 1 or 2 more things. So, here we go. We have our HUD. We've defined that. We're going to now let a blueprint inherit from our game mode. So right-click, create blueprint class based on generic game mode. And we'll just put it in HUD, I guess. We'll call it generic underscore BP for blueprints create. So we're creating a class and letting it inherit from our main game mode. We need to compile our C++ code again so it actually recognizes what we're asking for here. And again, I expect that's going to take 6.5 decades, as Unreal Engine does. I'm going to learn some video editing soon so I can just skip ahead of this compile stuff, because I understand that this is pretty annoying. But anyways, there we go, guys. That's all done. If we open up the generic blueprint, it asks for a player HUD class, and all we do is select player HUD, which is that HUD class that we made earlier. Compile and save. We'll make sure our HUD is compiled. Yep, compiled, saved, done. And the last thing, right? So if we hit play, it's still not working. Our thing is not there. And that's because this game mode that we made, this blueprint game mode that inherits from our main game mode, it's not set up to use this game mode. So if we go to project settings, maps and modes, and then we go to default game mode and change that to generic underscore BP, now should work. Yep, if we hit play, you can see our stamina's there, and that's slowly draining off, and we now have an interface. Very, very cool. We could do this with lots more stuff, and in another tutorial I will show you how to make this work with other things as well. Just to prove that this is working, let's just change our drain rate for our player's stamina to 0.1. So it should now drain 10 times faster, so we'll save and then compile, and when I play the game, our character's stamina will drain at a much faster rate. So if I hit play, as you can see, it's now going down a lot faster. So that's just one very basic HUD widget type thing in here, and in another tutorial I'll actually make this be a little more useful. Right now it's just draining stamina, and it doesn't matter what we're doing, our stamina is always draining. Doesn't really make any sense, but the idea is just to show you how to make C++ kind of interact with the blueprint side of things and get the HUD fully working. Hopefully you guys know how this works now, and in future tutorials we will add more functionality to this. We will do text, things like that, but this has just been a basic introduction to HUDs. Hopefully you guys enjoyed that. I will put out another part pretty soon, so see you guys in the next video.